All right, so what we're going to start talking about now is a concept that is very commonly used in real world exponential growth problems, especially at the bank. You'll see this word compounding pretty frequently in the real world, and all that it means is how often you are splitting up the interest rate or the rate of growth. Okay, so we're going to get into that and figure out exactly where it is that comes from. So Dan owes the bank, we'll start with this first problem, $20,000, and he's given a 4% interest rate on that loan. So how much does he owe the bank in 2 years? And this is a pretty easy thing for us to figure out. We know that if he pays nothing, that amount is just going to continue to grow. So we can look at this as just a regular old exponential growth problem where A equals $20,000. That's how much he originally borrowed. And if he's not paying it back, then that amount is going to grow by 4% every year. So in 2 years, what will that end up being? And it turns out that after 2 years, if he doesn't pay any of it back, he now owes $21,632. So he owes more because he didn't pay. So the question is, would it make a difference if we take that interest rate, that 4% interest rate, and we spread that interest rate out across the year? So here's what I mean by that. To start, this is what we did first in problem A. All right, we said that a year goes by, 4% interest gets added, right? And then another year goes by, this is year 2, and another 4% interest gets added. Okay, so that was what we just did, and we figured out that after all that happens, he ends up owing $21,632. What if we approach it differently, and we say that there's also this B scenario where 2 years still go by, so this is 2 years. But instead of it being 4% once per year, we're going to split these years in half. And we're still going to have it be a 4% interest rate each year, but we're going to do 2% of that in the first half of the year and 2% of that in the second half of the year. And we'll do it again in the second set. And we want to find out if that makes a difference. Will that be the same? Because, I mean, logically, it seems like it might be the same. At the end of every year, it's still 4%. So but would it make a difference how often we're spreading that amount across the year? All right, so this is what we call compounding. So this is compounding. And what we want to do is figure out, does it make a difference? And this is the exact scenario that we've got in part B here. So it says Dan owes the bank $20,000, 4% interest, compounded semi-annually. And that word semi-annually, that word is telling us how often we are cutting up our interest rate. So semi-annually means twice per year. And that's why we've chunked that 4% into 2 groups rather than 4 groups or 12 groups, for example. Okay, so semi-annually, that's telling us 2 groups per year. How much does he owe the bank in 2 years? So what we're going to do is we're going to figure this out 6 months at a time, half a year at a time. So what we'll do is we'll zoom in on this point in time. He borrowed the $20,000, half a year went by, and 2% interest was applied. Okay, so let's figure that out. So A of, we'll say 6 months, is $20,000 times 1.02, right? Just add 2% to the $20,000. And it turns out that equals $20,400. So if we're compounding, at this point here, he now owes $20,400. All right, now let's fast forward to another 6 months later. So move to the second 6 months. Starts off owing $20,400, and we add 2% to that. And when we put that into the calculator, we end up with $20,808. All right, so the end of year 1, he now owes $20,808. We still don't really know if this is going to end up being exactly the same, but we know that if we compound in that first year, we end up owing $20,808. All right, so we keep going. Let's figure out how much he owes after the third 6 months. So A equals, we're going to start with that $20,808 that he left off with at the end of the first year, and we're going to add another 2% to that, And this time we end up with $21,224.16. So right there, that's $21,224.16. And so then finally we go to the end of the second year. $21,224.16 plus 2% of that gives us $21,648.64. Okay, so now we can answer this question. Would it make a difference if we spread that interest rate across each year? Well, if we do not compound, we end up owing Dan ends up owing $21,632 at the end of 2 years. If we do compound, he owes $21,648.64. So does it make a difference? It definitely does make a difference, because this is a greater number than this. And it's just a teeny amount, right? We're talking $16 here and 64 cents. Not a big deal, but over many, many, many years, that may turn out to be a greater difference. So it does matter if we compound, and in fact, when we compound, we end up with a greater amount. So then part C extends this and says, what would Dan owe if the interest was compounded quarterly? And this is another one of those vocabulary words up here, kind of like semi-annually, which is telling you how many pieces to cut each year into. Semi-annually says to cut each year into 2 groups per year, and quarterly, as its name suggests, 4 groups per year. All right, so what we're going to do now is I'm just going to give you the formula, the adjusted formula that helps us figure this out without going step by step here. And when we initially came up with the first exponential growth formula, we derived it by going through the process. All right, we're not going to do that in this case. I'm just going to give you the formula. Okay, so this is our regular exponential growth formula, but with a couple changes. Remember that when we talked about changing time, we said that sometimes time gets adjusted. So that's what this A represents. You could use any variable there. So sometimes A is adjusted, but if it's not, then there is no A. Then A would just be 1. The difference here is now we have this N. And what N represents is how often you are compounding. So before we tackle this problem, I just want to address a couple of different vocabulary words that are often used in these problems. And it just tells you what your N is going to be. So if the problem says that the interest is compounded annually, what that means is to apply the interest rate once per year. So N is 1. And until today, N was always 1. We never even wrote N because N was just 1 in all of those problems. But now we're going to start seeing examples of compounded semi-annually, where N would be 2, or quarterly, where N would be 4, which is what we're about to do. If it's monthly, then we're figuring out, well, how many months are there in a year, because we're going to apply this every month, and there are 12 months in a year, so N would be 12. Weekly would be however many weeks there are in a year. Daily would be however many days there are in a year. And yes, there are leap years, but you don't need to account for that, okay? So all of these vocabulary terms are pretty frequently used, and so you just have to make sure that you're comfortable using any of them. So let's use our formula to figure out what Dan will owe if the interest rate is compounded quarterly. So we're going to use the same formula that we've been given above here. The total amount is going to be the principal amount, and in Dan's case, the principal amount is $20,000 times 1 plus the rate, which is 0.04, divided by N. In this case, N is going to be 4. Because that's how often we're compounding. To the power of. So time is not being cut into different amounts right now in this case. So T is being multiplied by whatever N is, and in this case, N is 4. So this is the formula that we use, and we can plug this right into a calculator. You can simplify this if you want to, but you could put that directly into the calculator as well. This turns out to be, just because 0.04 divided by 4 is 0.01, So it ends up working out that this is 1.01 to the, and in this case, t is 2. Should have probably plugged that in. And 2 times 4 is 8. So 1.01 to the 8th power, which, as it turns out, would be 21,657.13. Again, that's just a little bit more than what we got when we compounded semi-annually, right? This is just a little bit greater than this because we're compounding a little bit more often. And if instead of compounding quarterly, we had compounded monthly, it would be greater. And weekly would be a little greater than that. And daily would be even more. Okay, so what we're going to do when you guys come to class tomorrow is we're just going to practice evaluating some of these. So make sure that you're familiar with this new formula and how to apply these vocabulary words.